Hello, good day to you. Today I'm going to explain my test number two in order to finally finish my test. So my name is Juan Angel Garcia, and I'm going to explain chronologically from 1 to 8 in the questions we're talking to. So we're going to the first one. Let me just disconnect my phone. So we're going to the first one is I have to design a push down automaton that recognize A um, times is 2n b um, to the power of n. For example, AAB for A's and two B's, and I have to show the step by step in how did I do it. So as we're going to a push down automaton, the first thing we have to push the dollar sign button, and then what I did is every time I receive an A, I push an A and I start doing it. But once I receive a B, I pop the A, and then if I still have another A alone, I just start popping it. So if I see a B again, what should I do? Is I have to push the A again and going back to the Q2. But if not, we finally go to our final statement we where we push the this dollar sign. My bad. So yeah, this is what I did, and this is an example of how it's been doing. We're going to AAB. So as we have our stack, it's being popped, and then we receive an A and getting to the Q2. And if we receive another A, we should go to Q2 also. And as we're receiving the B, what we should go is pop A. So we're having A popped. So as we know that it's empty, we should pop again A, and we should have the dollar sign. So as we know we have this dollar sign, we already know that it's finished. So we push again the we pop the dollar sign, and should be empty to the final state and should be accepting A and B. It also accepts every A. Let's go for example A B should be the same one. So we push the dollar sign button, and then we push all the A's, and when we see a B, we start popping. We start popping, but we're going back to the B because we see another B, so we should be popping out. Eventually, we will be handing out to the final statement. I'm trying to be as fast as I can, and if you have any question, please let me know, and feel free to email me uh, anytime. So we're going to the number two. The number two, let me read it to you, is design a context-free grammar that will generate all the words of the A to the power of 2n, B to the power n in the language AAB, the same language, and I have to show step by step. So pretty much what I did, this was real simple. I created the vocabulary. So we have an epsilon because we're assuming that we have it empty. We're fine. We have a B and we have A as variables because they're the ones that you're giving me, and I'm giving the epsilon because it's already in the language. So it's epsilon A and B. So my vocabulary, it's my word AAB. So what I did, it's I accept epsilon because it's at the first part, and then I'm having AANB, AA space B. So I just go to the three of them, AA, and if I receive an S, I should go to epsilon, and finally a B. So AAB. So if we're going to the AAAAB again, should be AA, and then if we're having an S here should be, oh, I have it here, my bad. So we should be having A. But as we know, we're missing another A and another two A's. What we should be doing, it's doing another star state. We'd have the A again, the S and the B. So we're having two B's. We're having two B's and we're having the four A's. And we have the epsilon at the final, but we ignore the epsilon and we have the A, B, B. So we're going to number three. That was kind of tricky. So what I did is I used the general algorithm that we have in class to generate the context-free grammar, and we should go also for from S from the start point to going to the start point to the final point. We should have plus, minus, 0 or 1, and when we are in the final statement, we only accept 0 or 1s, and where we're going to sync, we accept all the kind of it. But to go to sync, we need the plus and the -1. So what I did is pretty much this one. I'm sorry about it. I have my star state, and as I haven't mentioned that we don't accept epsilon, so if we have a plus, a negative, a 0 or 1, we go to the final state, which is the accept state. If we have 0 or 1, we're still in the final state, but if we receive another plus or minus, we're going to sync with all the numbers. So this is a list of ways we can go. And finally, our diagram should be this one. When the start point, we're having the +1. Where we're going to the start point, we're going to the final state. So we're going to the final state and we receive a 0. We're still in the final state. You receive a 1. We're still in the final state. And as we're done, because you asked me to find the +0 1 number, we should go to the epsilon because we're done. We're done with because we have +0 and 1. And this is our B or 3 in order to know we're doing it correctly. So this is my CFG and this is my PDA. Oh, maybe I did it wrong. My bad. So in number 4, what we should be doing. So number 4, what we should be doing, it's I have to transfer step by step my rule S, which is the epsilon, and 1s to a Chomsky normal form. So that was kind of tricky. So what I did is basically we have the epsilon and the star state, and we have the star state and 1s0. So what you should be doing every time is we should be adding the star state, a new star state with an epsilon. But as I see there in the in the paper Dr. Diego gave us with the all destruction, they say when they have a null pointer, which is this one, the stars, they have a null pointer, you have to get rid of the S. So my stars point will be pointing to the S, and because we're getting a rate of the S, we should have 1 0. As we have the same, we should be copying because we're having the star state and we should get rid of it. It should be 1s0, 1 0. So at the final state, at the final part, what should be doing is changing the letters or the numbers you have into a variables. So I switch C1 to C and 0 to N. So here it's my star state, which is 1 and 0. I just put the letters I want, and Z as U should be a 0 because we have 1s0. So what I did is U should be a 0, but as I know that N is already 0, it's U a N. So a N should be O. So that with 1s0, 1 0. Okay, and this is just the complaints of how I did it, and then I just copy again my star state because it's pretty much the same. And finally, my 3 should be really easy because we already know, because we're putting 1 and 0, we already know that Z goes directly to 1 and N go directly to 0. So that should be it for it in the number 4. So let's go to number 5. It says transform the following SFG into a PDA when the star state is epsilon and also my star state is 1s0. And I have to show step by step the word then and how it should be accepted into my push down automata. So what I did is pretty much this fabulous CFG. So as we know, we have to pop S the dollar sign every time you see it. So from a star state to Q1 should go with we should pop the stars the dollar sign, and then we have to pop the star state. So we know when we know we have to pop the star state, we're going to create a Q loop. And this is the tricky part because as we're having to put 1 as 0, we should have to put it backwards at 0 as 1 because we're on a stack. So when we're putting in a stack, should be when we see an S, we should be popping the 0. So we should be popping the S and we should be popping the 1. So it's 0 S 1. So we're putting it into the stack. My bad. I'm sorry. And then when we see a 1 and a 0, because we have to put it with all the variables we have. So when we see see 1 and a 0, we you pop them. So you pop them, and then when we see a dollar sign, we should be get rid of the dollar sign. We popped it. When we see nothing in the stack, my bad. When we see nothing in the stack, we should pop S, and that should be everything, and that should be our final state. So when we're going to the as explained, where we're going to the stack, we should have the word 1 and 0. So when we're receiving 1, we're adding to the stack as dollar sign and then an S because we're starting and we're here. So should be one we should be adding 1 as 0. So we have the 1 and the S and the 0. So what I did, it's pretty much I go to the loop and I got the 0, which is this one, S, which is that one, and 1, which is that one. And you have it in your stack, but you should pop 1 because you want it. So you pop 1 and you still have the S. But as you don't care too much, you keep popping. You pop and you see a 0. You're still in the Q loop. When you see a 0, you pop it again and you have the 0 here. So it's 1, 0. And then you are all by yourself with a dollar sign when you should be here in the Q loop. When you see the dollar sign, you pop it and you're alone in the final step. So you're fine because you're stuck something. Okay. So for number 6, go to that one. So for number 6, we should transfer the following PDA into a CFG. This automaton has two states, my start state and my final state. Both of them are accept states. So when I have the algorithm here. This is my, oh my god, sorry. This is my PDA. So when we're in my PDA, when we're in S1 to S1, we should be pushing 1 to the stack. Okay? When we see a 1, we push 1. So when you see, when you go from S1 to S0, when you see a 0, you pop a 1. And in the S0, when you see a 0, you pop a 1. So the first rule is create my TR, P, and A. When my T, it's what is my first part, because we have to take the one who's popping, not the one who's pushing. We have to take the one who's popping. So my T should be 1 because it's the one is my source. It's the one that I'm reading. R should be my my source, or I'm getting it wrong. And my P should be my destination, which should be the same one. And my A should be what I'm popping. So A, my bad. A should be what I have, and T should be what I'm popping. So my T, R, P, and A should be one as one as one and one. So as we have two pushings here, we have to go one and two. So my Q, is my destination. So my destination should be S0. S should be my source. So it should be S1 because I'm doing 0, 1, epsilon, which should be this one. And B should be 0 because it's what I'm seeing. And in 2, it's pretty much the same, just that it has a loop. So my Q and my S should be the same because it's in a loop. So let me do it better now. So it'd be S0, S0, and 0. So we have our rule that is A P Q should be. Let me read it for you. Just give me a quick moment and I'll read it to you. So I believe it's recording. So it should be my first rule should be APQ, which is the one that I'm doing, should be A, which is this one, which is 1. A, again, which is the one that is the symbol A. R, RS, and then my B, which is 0. But as we're having two loops, which have to do it again, it should be different because we have different destination and sources than the one here. So as Dr. Diego told us that my APQ, APR, ARQ should remain the same because it's multiple ways of doing it. It's the multiple movements that you have, but finally, because it's too long to do it, it should be this one. And my AS1 should goes to epsilon, and my AS0 should go to epsilon. And my 3 should be this one with the start state. It's AS1 0, which is my PQ. Should go directly to 1 and should go directly to 0 and go directly to AS1 S1 and A source 0. So 0, which should go all the two of them directly to epsilon. That should be the correct answer to these questions. So as we're number 6 and I have only 12 minutes to do it and I don't want to do it too long, I'll try to uh, bust up a little bit. So are we doing number 7? Use the general stack base algorithm to show that's really simple. So as you know, the first thing you have to do is you have to add to the stack. The first thing you see, if you see um this I forget the name, this two. So as we see an open bracket, it's bracket, an open bracket, we put it into the stack, and we get the first operand that we have, operator, my bad, which is the plus sign, and then we put the two of them into the left side, and as we see a close bracket, we should pop what we have. So it should be 11, it should be 1, and then we pretty much the same. So you have 11, and then you have 1, and you start popping out. Should be 11. Oh, and my bad. You don't add it to the stack. I don't know why I did that. I'm sorry. You wrote it down. So you have 11, which is this one. You have 1. You wrote it down. And when you see a operator, as you see a closed source, you start popping out. So you have a plus sign. So when we're going to the divider, you get it into the stack, and then you see an open source, you see an open bracket, you open it, and you start writing it down. 20, and 17 because of the operands we have. And then the operator should be the minus. You got it? But you don't write it here. You put it into the stack. When you see the close source, when you start popping out. So you start popping, the minus. You should get rid of the close source, and you still have the dividend. So when you see the final dividend and it's all by itself and you already finish it, you just pop it and put it into your growth uh, move. So it should be this is the correct answer to that number 7. And finally, we're going to do the pumping lemma to show that the following language is not a context free. It's pretty much the same as within the quiz. When n should be greater or equal than 0, so my n should be 1. M should be greater than n, that should be 2. And k should be greater than m, that should be 3. So as I remember the last quiz, it was pretty much the same, that n, b, a, b, and c should be with the same n, with 1, 2, and 3. So this is my start state with a p, 2 p's, b, 2p, and c, 3p. So as we know, the length on my language should be greater or equals to p, which this one is fine. But as we're going to see here, we're saying that it's only contains a. This means that it only contains a is when it's empty. We only have a's. Is grading here, and this one here is that the length of my size should be containing only b's, and this one with the 3p is only containing c's. So it's breaking up here already, but as you want to see, the length should be less than my p, but as you see, my b, x, and y contains a and b's only because I'm using b, x, y. So in this one, when you see that it's greater, my b, x, y is greater, it only contains b and z's because it's greater. I'm using the 2p and the 3p. But in here, I'm only using the p and the 2p. This one and this one. So when I have an I equals to 3, it says that it not contains b. It doesn't contain b's. So that's bad. And in one point, I will have more A's, B's, and Z's than in other letters. This is kind of tricky how pumping lemma works, because you have to be very careful if it's broken the law. So it's I believe I'm not that good in order to express how is this working. But as I see it, is that even you have more A's, more B's, and more Z's, because you having 2p and 3p's, you will have always more B's than A's, and always you have more Z's than B's and Z's than A's. So as I see, it should be breaking your context. So it shouldn't be always the same. It shouldn't be A, B, Z, double A, double B, double Z. This should be A, double B, and 3Z's. And then when you multiply it, or when you go into the next one, should be double A, 4Z's, and it's just an expansion. So it should be breaking it as we're seeing it right now. So I'm done with the quiz, with the lab. My bad, with the test. I'm trying to do it as fast as I can because I already have 23 minutes, and I'll pause like a lot. So as you can see, I tried to do the best that I could. And if you have any question, please let me know, and I'll be free to answer your questions. And thank you very much. Thank you very much for seeing this video. I'll put it into YouTube, and you should be able to see it right now. If you're seeing it, thank you very much. Thank you very much, and see you into the test number 3.